Today we're going to go over polynomial division. So before we talked about factorizing polynomials and different methods to condense a polynomial function into what's called its factored form. Now we're going to look at how to divide polynomials. And we're going to start with some more simple type division. And then we're going to get to more and more complex numbers. So this first section is dividing polynomials by x with no remainder. So let me copy this first one here. The first one says, it gives us this rational expression, and it has an equal sign on it. It says x squared plus 2x over x equals something. And so here what we're going to do is we can cancel out what we can cancel out. Now, when we have a plus sign, that means that this bottom value is dividing this and that term. An easier way to think about it is we can factor the top. So if we factor out the greatest common factor from the numerator, that leaves us with x is the greatest common factor times x plus 2 would be left over. And then the divided by x or the over x is just going to stay the same. Now this says times, and we can cancel out these x's. X divided by x is just 1, and 1 times x plus 2 is just x plus 2. So that's going to be our final answer for this one. We factor the top and see if any common factors cancel out. So let's see if we can go to the next one here. Put the answer in and we can see the next one. Okay, this next one has a few more, or has an additional term on it. So this next one, the same basic idea. We're going to factor out the greatest common factor. And you would do this with the top and the bottom. But the bottom, there's nothing to factor out. There's just an x on the bottom. So the greatest common factor on the numerator, we can factor out an x squared, and that leaves us with x squared plus 5x plus 3. Divide all of that by x. Now we're just looking at these two. You can find greatest common factor, cancel it out. So now this is that x cancels with that, and that's just x to the 1. And it says answer should be a polynomial. So we're going to re-multiply this out. So that's going to be x cubed plus 5x squared plus 3x is our final answer. Now these are a little bit simple because we're just dividing by x. If it's easier for you, you can just say, well, x to the 4th divided by x is x to the 3rd. 5x cubed divided by x is 5x squared, and 3x squared divided by x is 3x. If that's easier for you, you can do it that way. But it's a good habit to factor out the greatest common factor, or use the AC method, or factoring by grouping whenever we see a rational expression. Because when we have rational expressions, being able to cancel things out, being able to cancel out different terms becomes really helpful for us in the future. Especially when we have these problems become a little more complex as we go. So we have another one with a minus. And that's still, this one we're still just dividing by x. I'm going to do this one without factoring. We'll just write the answer. This is 3x cubed minus 6x minus 1. So I didn't find the greatest common factor for that one. I just divided each term by x. Now, again, the reason we're dividing by x for all three is because there's a minus between the terms. If there isn't a minus, there's just a multiply, then we only divide what's being multiplied. We don't divide the rest of this part. So here there's a minus, we're just dividing all three of those by x. Okay, so that's fairly simple. There's no remainders here. The next part says that we're going to have a remainder. So it gives us some technical information. It says your answer should be in the form p of x plus k over x, where p is the polynomial and k is an integer. All this is saying is we should get some polynomial answer, and then we should get a fractional amount. That's all that's saying there. So let's take a look at this one. So 3x squared minus 10 over x, all over x. If we look at the numerator, we can't factor anything out of the numerator. There's nothing that we could factor at all. So what we're going to do is just look at this term by term. So if we divide 3x squared by x, this actually, if we write this out, it looks like this. And I didn't do this on the last problem. Probably could have done this on the last problem to show you, but I didn't write it out this way. But this is what it would look like when we divide by x. Divide both of these terms by x. This first one we can divide by x and we get just 3x. But this next term, we just have to leave it as 10 over x. There's no common factors there, so our answer just stays in that form there. So again, you can solve these first ones in a couple different ways. You can find greatest common factor. You can just divide by the terms separately. And this is what it looks like when you divide the terms separately. So you can write it out like that, or you can just do all mental math if you want to. Okay, let's look at another one with a remainder. So the remainder is the fractional part. Let me show you how we would do this with, let's see if we can try this with long division, just so we can get some practice with that. Well, that would take a lot more time. Let's not do long division. If we did long division, we have to write it like this: 0x to the fourth plus 0x cubed plus 0x squared plus 6x plus 2. If we did long division, let's just do long division. I'll show you how the long division works also. So we should get the same answer with long division as we do with the last method that we tried. So this is how we'd write it out with long division. We have to write these zeros here for placeholders. So x divided by x to the fifth divided by x is x to the fourth. Then we multiply these two together, and we get x to the fourth times x is x to the fifth. We're going to subtract that, and we just get 0x to the fifth, and this is 0x to the fourth. And put the x there, and this is just times 0. So we would do 0 times x is 0, and this is 0x. Well, I should really write 0x to the third makes x to the fourth. This is a little tough with all the zeros, but because there's 3 zeros that we have to go through. Basically, if we get through all these zeros, this ends up being 0x squared plus 0x. Now I'm just skipping ahead with the long division, and now we're to the 6x. So 6x divided by x is 6. And that leaves us with, we would put the 6x down here and subtract. We get 0x. 6x minus 6x is 0x. Bring the 2 down like that. Now we have this. This says 2 divided by x. Well, that's that's nothing. We can't do anything with that. There's nothing left to do. So this 2 is our remainder. So if you remember doing long division, maybe in elementary school, we would put like R2 for the remainder. But when we have a remainder of 2 here, we just say plus 2 over this value over x. So if you like doing long division, you can use this method. So our final answer would be x to the 4th plus 6 plus 2 over x. I think this way takes a lot longer than the method that we've been doing so far. But you can do long division if you like to do long division. So here, this is just x to the 5th over x plus 6x over x plus 2 over x. That's x to the 4th plus 6 plus 2 over x. So we get the same answer. And this is sort of maybe just a quick preview on long division. I believe the next lesson's going to be on long division where this isn't just an x. It'd be like x plus 5 or x minus 3 or something like that. When we have things like that, then we want to use a long division method. But for now, we're just dividing by x, so you don't have to do long division if you don't want to. Okay, so that's how to write the remainders. Now we're going to get into, I think this is the next section is long division. Let me double check here. No, it is not. So this next one is about factoring and finding common factors. So this just says divide the polynomial, and we want to simplify the polynomial as much as we can. So this is difference of squares. So this is going to be x minus 4 times x plus 4. All I did was factor out the numerator. And if you need to review that, you can go back to the previous lesson on difference of squares. Then we just write x plus 4. Now those cancel out, and we're just left with x minus 4 for our final answer. Okay, I think we can maybe step it up a little bit here. This next one looks like a quadratic that we have to factor. Yes. All right. So this one's a little bit tougher. This one we got to use the AC method again. So AC method will appear many times when we're dealing with polynomials and factoring polynomials. So here A times C is 1 times 20. That's 20. All the ways to multiply to get 20. 2 times 10. 1 times 20. 4 times 5. 5 times 4. And then all the negatives. -1 times -20. -2 times -10. -4 times -5. -5 times -4. Okay. So now we have to figure out which of these, if we added them together, would equal B's value. B is -12. So that would be these two here. So that means this is the top now is going to be x squared minus 2x minus 10x plus 20. We factor this by grouping, put a plus between, find the greatest common factor. That's an x for the first one. We're left with x minus 2. We're going to also write x minus 2 there. That means to make -10x, we have to do minus 10. And that was our minus 10 there as well. And then -10 times -2 is positive 20. So now we're going to merge these. This is x minus 2. This is x minus 10. So that's factored form for the numerator. Now I'm just going to write the denominator. Our denominator was also x minus 10. And we have a common factor group that we can cancel out. So our final answer for this one is x minus 2. Okay, so that's how we divide polynomials. We want to factor everything that we can factor out and then cross anything out that we can cross out. Okay, the last part is dividing again, but with remainders. And for this one, probably are also going to use the AC method if we can. Let's see here. Um, okay, so if you do the AC method and you can't factor it, that means that there's got to be a remainder or something left over. So this one we're actually going to use long division. So if you get stuck and you're not able to factor it, if you do a times c is -4, well, -4 times 1, -2 times 2, 1 times -1 times +4, and then we have -2 times 2 again. None of those equals 6. So if you try the AC method, you'll get stuck. So if that happens, you're going to want to use long division. And so this is long division. We write everything in descending order, and if it skips an exponent, we put the placeholder like we did in the last example there. So now we do how many x squared minus 1s go into x squared plus 6x? Well, we just look at the first term here. We can multiply that by x only. So now we multiply all this. X times x minus 1 is x squared minus x. Put that all in parentheses, subtract that from the top here. So this is x squared minus x squared is 0. This is now positive x. 6x plus x is 7x. Bring this -4 down because we do that in long division. We bring the next term down. Okay, we're going to do the same thing. X minus 1. How many x minus 1s go into 7x minus 4? Well, we just look at the leading degree there. So this is plus 7. 7 times x minus 1 is 7x minus 7. We're going to subtract all of that. Those cancel. Negative goes to this -7, so it's a positive 7. Minus 4 is 3. That's our remainder. So we say plus 3 over that value. And so this is our final answer. Okay. So I think yes, that's everything for quiz 1 for polynomial division. So you can get polynomials without a remainder and and cancel out common factors. And if you're not able to do AC method, that's when you would do long division.